7a. Find sets of values of x for which 3 into bracket 2x plus 1 close bracket greater than 5 minus 2x. So the first thing we need to do is expand the bracket. 6x plus 3 is greater than 5 minus 2x. Therefore, 8x is greater than 2 and x will be greater than a quarter. Question B. Find the sets of values of x for which 2x squared minus 7x plus 3 is greater than 0. At this point, I'm going to say a equals 2, b equals minus 7, and c equals 3. So what I need to do is find AC. AC is 6. I need two numbers I can multiply together to get 6. And when I add them together, I get b equals minus 7. So I get minus 7. And the two numbers I'm thinking, minus 6, minus 1. With minus 6 minus 1, all I need to do is put x here, minus 6x, and minus x. Now if I take minus 6x minus x together, that would be minus 7x. So that fits into the equation there. So I can replace minus 7x with minus 6x minus x. So right, I get 2x squared minus 6x minus x plus 3 greater than 0. Now there's a common factor here. Between those is 2x, and there's a common factor here is minus 1. So let's do that. 2x, I get x minus 3 minus 1, I get x minus 3, all greater than 0. Right, x minus 3 are common factor here. So I get x minus 3 common. Also, 2x minus 1 is left. 2x minus 1, both greater than 0. Therefore, if I draw a line here, therefore I need to set this to greater than 0 each of the two factors. So I get x minus 3 greater than 0, x is greater than 3. So that's one root. I also have 2x minus 1 greater than 0, x greater than a half. That's the second root for the quadratic here. So if we're to write the domain for these sets of values, let's quickly sketch it. That's a quick sketch. If that's a half and that's 3 here, I get a half here and that's 3. The intercept on the y-axis is this 3 here plus 3. So that will be here somewhere. And that graph can come down nicely from the second quadrant through the roots up there. Now the values we're looking for are the values of y greater than 0. The values we're looking for is says this function fx, y is greater than 0. So we're looking for the positive values here, not below 0 here. This is less than 0 here, less than 0, greater than 0. So what we're looking for is the values which are these values here. So that's greater than 0, that's greater than 0. What are those x values? So that's what we've been asked to write. So the x values are what we call domains. So you can see I'll draw an open circle, because the values does not equal to 0. It says greater than 0. So we'll draw open circle. To do the domain, and then I'll do open curly bracket, x colon, x is less than a half, right? Because these values are less than a half, where the function is positive. Close bracket, close curly bracket, and then union, that means or plus, or, and then open curly bracket, x colon, because we're talking about x-axis, so this is the x-axis here, so we're talking about the x-axis. X is greater than 3, close the curly bracket, and that is the domain that we've been asked. That's the set of values of x that we've been asked to write on. Question C, we need to do both the linear here and the quadratic. So the best way is to sketch that curve. So the best way is to sketch the curve properly. So I'm going to draw a line here. And so I'm drawing the x-axis here. So we know that one of the points is a half and the other one is 3. And the intercept is also 3 here, right? But for the linear version, for the linear, x is greater than a quarter. So I have to find my quarter here and draw a line down there. So that's x equals a quarter. X equals a quarter. Because it's not actually going to be equal, it's going to be greater than it. So we do that. Open circle. Also, it's not equal to a half, so that's a half. It's not equal to 3 either, so that's just a 3. Now, and this is 3 here. So the curve is coming here. Let's draw the curve. So that's the curve going through that way. And we are looking for the region where x is greater than a quarter. That's a quarter here. So x is greater than a quarter, so that'll be that region here. So if we sketch that region here is greater than a quarter and less than a half. So those are the two regions we're looking at. And we're also looking at that one where x is greater than 3. And that's the domain we want to write. So to write the domain for this one, we say the domain is going to be curly bracket, x colon. Right. So the first one is a quarter. We always start with the smallest. It's less than x, which is also less than a half. A half is the highest. So we're going from there to there. That's what we're going from. And then we close the curly bracket. So that's one part of the domain. And then we say union, which means or plus, that's plus. So that's union. And we go. And then we write x colon, because we're talking about x-axis. X is greater than 3. And then close the curly bracket. And that's the sets of value for both the linear. So this is the linear. And that is the parabola for quadratic. For the quadratic. Don't forget to label your axis, as that's your x-axis, and that's your y-axis. Minus x minus y. Equation of the y-axis is x equal to 0. Equation of the x-axis is y equal to 0.